Okay, so let's look at what logical implication we have. We have premise 1 implies conclusion 2. So we have different possibilities that we could have. The premise could be true, the conclusion could be true, and the answer is yes, we are good. Here we have a problem. Here the premise is true but the conclusion is false. We want to make sure that this never happens. If our proof is to be valid, we want to make sure that this never happens. Let's look at this. Does P implies Q logically imply Q? We can fill in this truth table for P implies Q and Q. Make sure that you agree with the truth table and you know how I got the truth table. If not, review the earlier module, and also this would be something you should discuss in your group. I have one instance here, the last row in particular, where the premise is true but the conclusion is false. That means this is an invalid proof, because I don't ever want a situation where premise is true but the conclusion is false. I want to make sure that that never happens. Okay, let's look at the next example. Here I have P and P implies Q, logically implies Q. We can again do the same thing as before. We can create the truth table for premise. So this would be the truth table for the premise. This is the truth table for the conclusion. And the question is the conclusion true whenever the premise is true? Right here, both are true, we are good. Here the premise is false, so I don't really have to worry about the conclusion, so I'm good. Here as well. Here also the premise is false, I'm good. Here premise is false, I'm good. And I have yes in all of these rows, and that means that this is a valid proof. Every instance where the premise is true, the conclusion is true as well. So what is the relation between W logically implies C and W implies C? We can look at this. In W implies C, this one row had a false entity because W was true but C was false. Here we are going to say that W does not logically implies Q. And essentially that means W logically implies C is saying that W implies C should be a tautology. I should never have a false instance in my implication. Let's look at this example. So what I have done here is this part, first 6 columns are identical to what I had on the slide before. Here I have added another column that asks the question, if I replace this logically implies by just a regular implies, then do I have a tautology? And we can evaluate the formula. We can take this and this to evaluate logically implies, to evaluate implies, and we can find that in each instance this formula evaluates to true. That means this formula is indeed a tautology. That's exactly what we are looking for as the relation between logically implies and implies. What I want you to be able to do here is make sure you understand how I have built the truth table, and the fact that how we are relating that all true values over here to this, which is whether the conclusion is true whenever the premise is true. Once again, we have reached the check before you go ahead slide. So I want you to be aware that the key of the logical implication was every time the premise is true, the conclusion had to be true. Note that this is every time. We want this to be true always, not almost always. Always is not the same as almost always. If the premise is false, then it doesn't matter whether the conclusion is true or not. It is okay if it is true, it is okay if it is false. However, if the premise is true, the conclusion must be true. We had an instance of an invalid logical implication earlier on the slide. I want you to be sure about that you have understood what went wrong there, and if you haven't, this would be a good thing to make sure that you discuss it with the TA or me.